given signal x of t, h of t. First step, we rewrite our x of t, h of t by x of tau, h of tau. Okay, this t replaced by a dummy variable tau. Then we have to plot x of tau signal and the h of t minus tau signal. From x of tau, h of t minus tau signal only, we will come to know the integration limits and from where to where this equation is valid and all. Okay. So before that, we have to do some rough work. So what is that rough work? This is common for all the problems. First, plot tau versus x of tau. Tau versus x of tau. X of tau equal to e power minus 2 tau into u of tau. Okay. So u of tau available from 0 to infinite. So negative side, no signal. E power minus 2t or e power minus 2 tau. So your signal will go like this. Okay. So this is a signal sketch for e power minus 2t into u of t or e power minus 2 tau into u of tau. Next, h of tau. H of tau. Tau versus h of tau. U of t plus 2. U of t plus 2 meaning your signal started in advanced by 2 units of time. So signal starting from here, magnitude 1. Okay. But as per the formula, we need x of tau, h of minus tau. X of tau, h of minus tau. So h of minus tau you plot it now. H of minus tau plot. So now 0, 1, 2. This is the signal diagram for h of minus 2. Okay. Because h of t equal to u of t plus 2. So minus 2 to infinite. U of minus tau meaning minus infinite to 2. Okay. Now, what are the signal we need? X of tau we need. Tau versus x of tau 0. Next, what we need? We need h of minus tau only. We need h of minus tau only. H of minus tau signal sketch. It start from infinite, end with 2. Okay. This is nothing but your t equal to 0. That's it. Okay. That is your small t equal to 0. At t equal to 0, what is the diagram? Okay. So x of tau, h of tau. Now, if you multiply these two signal, look at this. 0 to 2, minus infinite to 0, 0 some value, but here minus infinite to 0, nothing is there. So 0 multiplied with any value, you will get 0. Where? From this portion. From this portion? No. But 0 to 2, some signal is there. Here 0 to 2, some signal is there. Yes. So now if you multiply x of tau, h of t minus tau at t equal to 0, we will get some value for y of t. Right? Okay. Next, these all are rough work. Okay. Next, can we draw h of minus tau minus 1? This is a diagram for h of minus tau minus 1 or minus t equal to minus 1. Okay. T equal to 0, this is the signal. T equal to minus 1. Once we find reverse, minus tau minus 1 meaning left shift. Okay. After this time reversal, if you want to perform minus tau minus 1, left shift. Now check your x of tau, h of signal. So 0 to 1, still 0 to 1, these signals are available. So when you multiply this signal and this signal, you will get some y of t output. Right. Next step. Further try to shift your signal left side. Further try to shift your signal left side. That is h of minus tau minus 2. Minus tau minus 2. Your signal starting exactly from 0. Now also at tau equal to 0, at tau equal to 0, exactly the overlapping started. Okay. So, but when you draw the signal, when you draw the signal, h of minus tau minus 3, when you draw the signal h of minus tau minus 3, first problem, so I'm explaining step by step. Once you familiarize with this concept, then you can directly go to the problem. So this is the sketch for h of minus tau minus 3. Okay. Now multiply your x of tau and this signal. Will you get any value? X of tau into h of minus tau minus 3. Will you get any value? Please check. Minus infinite to 0, 0. So 0 into anything 0. Okay. So why I'm shifting my signal left side minus tau after plotting h of minus tau, we have to check minus tau minus 1, minus tau minus 2, minus tau minus, and so on until where the overlap is completed. So in this example, up to t equal to minus 2, the product of x of tau h of t minus tau is valid. Okay. So further, if you shift, there is no common region between your x of tau and h of t minus tau. Okay. So this is t minus tau diagram at t equal to minus 3. This is t minus tau diagram at t equal to minus 2. This is t minus tau diagram at t equal to minus 1. So from this case, so what we concluded now, y of t equal to 0 for t is less than 2 minus 2. When t is less than minus 2. See, at t equal to minus 2, exactly signal start at tau equal to 0 available. X of tau at tau equal to 0 available. Okay. When it is less than minus tau, less than this side, there is no common region between x of tau, h of t minus 2. So y of t equal to 0 for t less than or equal to minus 2. Okay. So at 0 overlap just started. At 1 signal is there. At 2 signal is there. Then substitute at t equal to 0 signal is there. Now draw the signal for minus tau plus 1. If you draw the signal for minus tau plus 1, then you will get the signal like this at 3. So overlap is at 4. So x of tau exists from 0 to infinite. So now if you shift your h of minus tau signal right side, that is minus tau plus 1 plus 2 plus 3 and so on, the overlap is available. The entire region, the overlap is available. So these all are rough work. So how to solve this problem? What is this integration limit for this problem? Integration, what is this limit from where to where? So already we identified y of t equal to 0 for t less than minus 2. Exactly, but minus 2 or minus 1, 0, 1, 2, 3 and so on, overlap is there. Okay, x of tau is infinite signal. So if you shift minus tau plus 1, minus tau plus 3 and so on, partially your h of t minus tau diagram partially will get overlap with this x of tau diagram. Okay. So now these all work you have to do in rough sheet. Okay. Now you draw the signal tau versus x of tau, tau versus x of tau. Next, draw the generalized diagram. H of t minus tau diagram. H of t minus tau diagram. How to draw the t minus tau diagram? Where is h of minus tau is there? This one. There you are just adding plus t, meaning 2 plus t. Okay. From h of minus tau, what is the end point? Tau equal to 2. So 2 plus t. Here minus tau plus infinite, minus infinite. So h of t minus tau. I'm drawing that signal somewhere here. Okay. This is t plus 2. Okay, there 2 is there, just plus t. Here minus infinite plus t, minus infinite. Okay, h of t minus tau diagram for t is greater than or equal to minus 2. This t may be minus 2 exactly, or minus 1 or 0 or 1, 2, 3, anything. That's why I given t greater than or equal to minus 2. When t less than minus 2, no signal. So only this answer is required in your answer script. X of tau diagram, h of t minus tau diagram. In this example, only one kind of overlap available. For t is greater than or equal to minus 2, partially this t minus tau diagram will be get overlapped with this x of tau, because x of tau infinite, 0 to infinite. So you can solve this problem with one step, one integration only. Okay. For doing this, to identify when your y of t equal to 0 and to draw your h of t minus tau diagram, then you have to do all this basics groundwork, x of tau, h of minus tau, then minus tau, minus 1, minus 2, minus 3, and so on, minus tau plus 1, plus 2, plus 3, and so on, and check where the overlap is not there. At what value of t there is no overlap between x of tau, h of t minus tau. In this example, we identified when t is less than minus 2. If the signal shifted further left side, there is no common region between x of tau, h of t minus tau. So this product is 0. X of tau, h of tau, t minus tau will be 0. That we identified in this example, y of t equal to 0 for t less than minus 2. So now, what is the equation for y of t? What is the equation for y of t for t is greater than or equal to minus 2? Only one kind of overlap, partial overlap only. So now what should be your integration limit from this example? Can anyone tell? From this graphical representation, x of tau is there, h of t minus tau is there. Okay, now we have to solve for y of t. We have to solve for y of t for t greater than or equal to minus 2. For t greater than or equal to minus 2, generalized h of t minus tau as per the formula x of tau h of t minus tau into d tau. So sketch x of tau, sketch is done. H of t minus tau at t is greater than or equal to minus 2, sketch is done. What is the integration limit?
0 to t plus 2.
0 to t plus 2. We don't know what is the value of t. This t may be minus 2 or greater than minus 2, any value. So write general expression for t is greater than or equal to minus 2. So when you look at this signal, here nothing is there, here nothing is there, but here some signal is there, but 0 into something 0. So starting overlap 0. Your lower limit for integration 0. Upper limit for integration is t plus 2. X of tau. What is x of tau? E power minus 2 tau into u of t. U of t value 1. H of t minus tau. H of t equal to u of t plus 1. Sorry, t plus 2. That is a value u of unit step signal. The value is 1 only. So you'll get 1. Okay. H of t minus tau, here value 1 only. U of t plus 2. Okay, u of t plus 2. U of t plus 2 magnitude is 1 from minus 2 to infinite. So if you look at this t minus tau diagram also, the magnitude is 1 only. Okay, so substitute 1. That's it. Now if you solve, you will get your y of t. Y of t. So with respect to tau, e power minus 2 tau divided by minus 2. Now substitute the value for tau, the limits 0 to t plus 2. The limit 0 plus 2. So substitute e power minus 2 t plus 2. Okay. Shall we take minus 1 by 2 outside? Minus 1 by 2 outside. So e power 0, 1. Or if we multiply minus inside, 1 minus e power minus 2 t plus 2 divided by 2. This is your y of t, convolution result. So this is valid for that you have to write very clearly. This is valid for when t is greater than or equal to minus 2. Otherwise 0. Okay. This way you have to solve this continuous time convolution problem. Any kind of problem, this is the procedure, graphical method. X of tau, h of minus tau, that is at t equal to 0. H of minus tau is equivalent to h of 0 minus tau, that is t equal to 0. Now substitute t equal to 1, so minus 1, h of minus 1 minus tau. Okay, then substitute t equal to minus 2 and check at what value of t your y of t becomes 0. That point you have to identify. And further check for right shift also. In this example, when t is less than minus 2, 0, when t is greater than or equal to minus 2, we are getting only one kind of overlap. Because x of tau 0 to infinite. So if you shift your signal right side again and again, anyway partially the h of t minus tau signal will get overlap with your x of tau. So you can solve this problem with only one step by sketching x of tau, h of t minus tau diagram. This is a generalized diagram. How to draw the generalized diagram? Check h of minus tau diagram. Where is minus tau diagram? This one. You modify this h of minus tau diagram to t minus tau diagram. Just adding t with this point. 2 plus t. Here minus infinite first. Now you will get, okay. Now if you look at these two signal, you can clearly understand the integration limit from 0 to t plus 2. What is t? Greater than or equal to minus. It may be minus 2. It may be minus 1. It may be 0, 1, 2, 3 and so on. So do you understand how to perform the convolution?
Yes, sir.
So one more, another method. Here you have to understand the concept only, okay? Any signal may be given, but simple problem you may expect. X of t equal to u of t plus 1 and h of t equal to u of t minus 2. So find convolution integral. Find convolution integral or convolution between these two signals. So what are the steps in the rough work? There are 4. The rough work. Plot tau versus x of tau. Plot tau versus x of tau. T plus 1. So signal start from minus 1 to infinite. Magnitude 1. Tau versus h of tau. H of tau t minus 2. So 0, 1, 2. Okay. This is h of tau. H of minus tau. H of minus tau. Zero, minus 1, minus 2. You know, 2 to infinite. H of tau. H of minus tau. H of minus tau.
Minus
Okay.
infinite to minus.
Minus infinite to minus tau. Right. Now you analyze. Now you analyze these two signals. For that, x of tau. Tau versus x of tau. 0, minus 1. X of tau is fixed. Okay, x of tau is fixed. We are not touching x of tau. Only we are shifting h of minus tau only. So exactly at this particular point. Exactly at this particular point. Tau versus h of minus 2. What is minus tau? Minus 1, 0, minus. Signal available minus infinite to minus 2. Okay, this is the signal sketch. Or this is equivalent to t minus tau. When t equal to 0, h of t minus tau become h of minus tau. Now multiply your two signal x of tau, h of t minus tau at t equal to 0. Will you get any value? Check here. From minus infinite to minus 1, nothing is there. Here minus infinite to minus 2, some signal is there. If you multiply now x of tau, h of t minus tau at t equal to 0, will you get any y of t? Any common region is there between these two? This is 0.
No, sir.
0. No. So in this example, y of t equal to 0. Right. So here itself y of t equal to 0. Now if we draw minus tau minus 1 diagram again, minus tau minus 1, then your signal from minus infinite to minus 3. Then you won't get any overlapping. Okay. Right. So now check at what t value your signal started getting overlap. And h
Yes,
of
sir.
minus tau minus 1 also, for h of minus tau minus 1 also, y of t equal to 0, because this signal will be left shift again, right? Okay. Next, can you draw the sketch for h of minus tau plus 1? Can you draw the sketch for h of minus tau plus 1? And check whether overlap exists or not. Tau versus h of minus tau plus 1, that is t equal to 1. So this is minus 2. So minus after h of minus tau plus 1 represent, okay, value. Now check x of tau, h of t minus tau, h of t minus tau at t equal to 1. At t equal to 1. Is there any overlap? Tau equal to minus 1. Here, tau equal to minus 1. Exactly signal starting. Okay. Now exactly when t equal to 1, when you multiply x of tau, h of t minus tau at t equal to 1, yes, signal possibility is there. Just the signal starting. Either here the signal is just ending, here the signal is just starting. Understand, no? So in this example, y of t equal to 0. When t is less than 1. When t is less than 1, at this position. Plus 1 meaning exactly the signal started. Okay. So if it is less than this 1, we have to look at this one only. If it is less than 1, then only the signal not there. Exactly t equal to 1, the signal is just started overlapping. Okay. Now try to draw minus tau plus 1 already there, minus tau plus 2, minus tau plus 3, minus tau plus, this is infinite signal. So minus tau plus 1, minus tau plus 2, minus tau plus 3, partially your h of t minus tau diagram will be overlapped with your x of tau. Okay, so these all are rough work. X of tau, h of minus tau. Now we check x of tau, h of t minus tau. No, y of t 0. So minus tau minus 1, it will shift further left side. No overlap. So try to shift right side, that is t equal to 1, minus tau plus 1. Yes, signal exactly started. When you draw the signal minus tau plus 2, your signal will become like this. Signal become like this. This is for h of minus tau plus 2. Okay. So you will get the overlapping region. So this is h of minus tau plus 2. That is t equal to 2. Okay. At t equal to 1, just overlap started. At t equal to 2, minus 1 to 0 overlap. At t equal to 3, some more point. So now you understand y of t equal to 0 for t less than 1. When t exactly equal to 1, overlapping started. T equal to 2, overlap is signal, common signal is there between x of tau, h of t minus tau. Right. As we discussed in the problem number 1, now you draw your h of t minus tau generalized diagram. Tau versus x of tau. Tau versus x of tau. Minus 1 to infinite, the magnitude is 1. Now draw h of t minus tau diagram when t is greater than or equal to 1. Tau versus h of t minus tau diagram. Where is h of minus tau diagram? This is h of minus tau diagram. What is the starting point? Minus 2. So t minus tau or minus tau plus t. Okay. So here the signal is the variable tau value minus tau plus t. Minus tau plus t. So I'm draw somewhere between like this. This is minus 2 plus t. Okay. Here minus infinite plus t. This is the origin. So h of t minus tau diagram for t is greater than or equal to 1. This t may be exactly 1 at this point. Or this t may be 2 at this point. And 3 at this point, 4 at this point. So you draw the generalized diagram, h of t minus tau diagram, when non-zero value of t. Okay. Non-zero value for y of t. Okay. So here also only one kind of overlap. Here also only one kind of overlap. Here also only one kind of. If you shift your t minus tau diagram, when t is greater than or equal to 1, t1, 2, 3, 4, 5, and so on, partially your h of t minus tau signal will get overlap with this x of tau. Okay. And we already found y of t equal to 0 for t less than 1. Now can you write the expression, can you solve your y of t for t is greater than or equal to 1? Can anybody tell the integration limit now?
Minus
What is the
1 to
low?
t minus 2, sir.
Minus 1 to
T
t
minus 2.
minus 2. Minus 1 is the lower limit, t minus 2 is the upper limit. This t may be 1 or 2, 3, and so on. Okay, that's it. Very simple. This region, for example. We don't know what is this value. That's why we written general value for t greater than or equal to 1. Okay, minus 1 to t minus 2. So x of tau, in this example, both are unit u of some function. So x of tau, h of t minus tau, magnitude is 1, 1. Okay, 1 dot 1. So d tau integration tau minus 1 to t minus 2. So t minus 2 minus of minus 1. So t minus 2 minus into minus plus 1, you will get t minus 1. Y of t equal to t minus 1. Okay. So you have to write down the final result like this. Y of t equal to y of t equal to t minus 1 for t is greater than or equal to 1, 0 for t is less than 1. This way you have to write down. Okay. Or if possible, you can draw the signal sketch also, but not necessary. This expression is sufficient. If it is small expression, very simple expression, t versus y of t. 0, 1, 2, 3, 4, 5, minus 1, minus 2. So y of t equal to 0 for t less than 1. So up to this 0 only. At 1, 1 minus 1, 0. At 2, 2 minus 1, 1. At 3, 3 minus 1, 2. 4 minus 1, 3. So your signal will go like this. Okay. So this is your y of t signal. So for the given x of t, h of t, the LTI system output is like this: t versus y of t. Okay. So do you understand how to solve this continuous time convolution problem? It's not difficult. It's very easy only. But you have to understand the concept clearly. X of tau, h of tau, h of minus tau. Then try to shift your h of minus tau signal from left side, from minus infinite to plus infinite actually. But initially you check minus tau minus 1, minus tau minus 2, minus tau minus 3, and check when your y of t is 0, when your y of t is valid. So accordingly, you then draw the generalized diagram of x of tau, h of t minus tau. From the generalized diagram only, you can find your integration limit easily. Second problem also same. First rough work. In the examination, x of tau, h of t minus tau generalized diagram. This is sufficient. Remaining all work, you do it in the rough page. You understand the problem first. When overlapping is there, when overlapping is not there. If overlapping is there, whether only one kind of overlapping is there during the entire value of t. In these two example, partially your h of t minus tau diagram will be overlapped with x of tau. But some other example, for some value of t, partially the signal will get overlapped. For some value of t, any one of the signal will overlap completely with another signal. Then again for some value of t, the partial overlapping cases will be occur. So that time, how to solve the problem? That's very important. Okay. So there only you have to use different kind of integration limit for different t value. So I'll solve that problem also. With this, you can able to solve any kind of given problem in continuous time signal conversion. So third example, x of t equal to 1, x of t equal to 1 when t between 0 to 2. Okay. In this example, there are different kind of overlap. You can experience different kind of overlap. This is a problem. Okay. Find convolution integral or convolution between these two signals. Find convolution between these two signals. Okay. So first do the rough work. Before drawing x of tau, h of t minus tau generalized diagram, we have to do some rough work to understand the integration limit. What value we have to substitute? X of tau versus x of tau 0, 1, 2. So 0 to 2, magnitude 1. Okay, this is x of tau diagram. H of tau, tau versus h of tau, 0 to 3, 0, 1, 2, 3. Okay, this time you have to show it clearly, then only you will see the difference. X of tau, h of tau is over. As per the formula, we need h of t minus tau diagram. Before drawing the t minus tau diagram, you draw h of minus tau diagram first. So 0 to 3 is h of tau. So h of minus tau, minus 3 to 0. Okay, minus 3 to 0 is where h of minus tau. Or this is equal to t minus tau diagram at t equal to 0. Now at this point, when you multiply your x of tau, h of t minus tau, your y of t is valid. Check. Yes, at tau equal to 0, exactly the signal is starting. At tau equal to 0, exactly the signal is ending. Okay, so at this point, when t equal to 0, when you multiply your x of tau, h of t minus tau diagram, as per the formula, integration x of tau, h of t minus tau into d tau, this product is valid, right? Okay, now check h of minus tau minus 1, h of minus tau minus 1, or h of minus 1 minus tau when t equal to minus 1. When t equal to minus 1, 0, minus 1, minus 2, minus 3, minus 4. This is your signal sketch. Okay, now check your x of tau, h of t minus tau product. X of tau signals between 0 to 2 only available. H of minus tau minus 1, 0 to 2, no information. Okay, here all 0. So 0 multiplied with any signal, your y of t becomes 0. So from this you can conclude, y of t equal to 0 for t less than 0, not less than or equal to, because at exactly equal to signal ending, their signal starting. So you have to mention when t is less than 0, when you shift the signal left side, okay, or t less than 0, there is no overlap. So y of t equal to 0, right? Next, try to shift your signal right side. Try to shift your signal right side. Minus tau plus 1, minus tau plus 2, minus tau plus 3, and so on. Can you do it? This is for 1, 2, 3, 4, right? Minus tau plus 1 meaning minus 2 to 1. Minus tau plus 2 meaning minus 1 to 2, and so on. Okay. So in this example, you will get initially partially the signal will get overlap. Then the signal will overlap, entire signal will get overlap. Then again you'll get partial overlap. That I will explain to you clearly. So don't think complicated that I am drawing so many diagrams. This is for all for your understanding purpose only. So 0 to 2, x of tau. H of minus tau plus 1. H of minus tau plus 1. 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, and so on. Minus tau plus 1, how to draw it? Where is minus tau diagram? This one. So minus 2 to 1. You get the signal minus 2 to 1. minus 2 to 1. Okay. Now see, partially this signal will get overlapped with this signal. Okay. Next draw the signal for h of minus tau plus 2 or 2 minus tau. So minus 1, 0, 1, 2, 3, 4, 5, 6, and so now signal minus 1 to 2. See now, this 0 to 2 entire portion will get overlapped with 0 to 2. This is called full overlap. This is called partial overlap. Partial overlap. The portion of the signal of h of t minus tau overlapped with your x of tau. That is partial overlap. Now at this case, 0 to 2, here also 0 to 2, x of tau entirely overlapped with h of t minus tau diagram. Or in some cases, h of t minus tau diagram will get entirely overlapped with this x of tau. This is called as full overlap. This is called as full overlap. Okay. Entire any one signal completely overlapped with another signal. So in this case, how to substitute the integration limit? That are the questions. Okay. Next, further you sketch the signal. Minus tau plus 3. Can you draw the signal for minus tau plus 3? Minus tau plus 3. So 0, 1, 2, 3, 4, 5, 6. So signal from 0 to 3. Okay. Now check your signal. 0 to 2 only will get overlap. Okay. Still your x of t completely will get overlap. Still your x of tau completely will get overlap. So in this case also you will get full overlap. Okay. Next, draw the signal for h of minus tau plus 4, that is t equal to 4. So 0, 1, 2, 3, 4, 1 to 4. Okay. Now again partial overlap. So only this 1 to 2 portion will only get overlap. Okay. This is called as again partial overlap. Okay. Now minus tau plus 5. This all signal sketch is not required for your examination if you understand the concept. 2 to 5. Exactly at 2 signal starting, there are 2 signal ending. This is h of minus tau plus 5. So minus tau exactly at t equal to 5 signal ending starting here. In x of tau signal ending here. Right. So now if you shift further right side, that is when you shift minus tau plus 6, your signal would become 3 to 6. No overlap. So now y of t equal to 0 when t is greater than 5. So in this example, y of t equal to 0 when t is greater than 5, y of t equal to 0 when t is less than 0. Okay. This case also y of t 0 and this case also y of t 0. In between cases, x of tau h of t minus tau is valid. Now how to solve this problem? You cannot solve this y of t with a single integration. Why? Different kind of overlap. At t equal to 0 just started. T equal to 1 partial overlap. T equal to 2, T equal to 3 full overlap. T equal to 4, 5 partial overlap. So you have to solve your y of t. You have to solve your y of t in 3 different cases. In 3 different cases. Y of t for partial overlap, initial partial overlap. Y of t during the full overlap cases. And y of t again partial overlap cases. You have to solve your y of t in 3 steps. Single step not possible. Okay. So far, do you understand the concept? How to solve this kind of problem? If two signals are given like this, both are finite. If one signal finite, one signal infinite also, this will happen sometimes. So do you understand the concept first? Why we need to solve y of t for this particular problem in 3 different steps? Why not possible with a single y of t expressions? The reason is you are getting different kind of overlap. Go back to the previous problem. If you shift the signal right side, anyway partially the signal will get overlapped. Second problem also same cases. The signal partially will get overlapped with this. But this third example, initially partial overlap, then fully overlap. Any one signal completely overlapped with other signal. Either x of tau completely overlapped with h of t minus tau, or h of t minus tau will completely overlap with x of tau. That condition, that case considered as one kind of integration solving. Okay. Please respond. Do you understand now why we go for 3 steps of y of t?
Yes, sir.
So we continue or next class we'll see? For solving this, you can draw your x of tau, h of t minus tau generalized diagram. Now you draw tau x of tau 0 to 2, 0 to 2. So now draw your h of t minus tau diagram, your h of t minus tau diagram in this case. This is h of t minus tau diagram when t between 0 to t. Okay. This is case 1. When t between 0 to 2, what is the integration limit? How to draw t minus tau diagram? Go back to minus tau diagram. H of minus tau diagram. This is h of minus tau diagram. T minus tau minus 3 plus t, 0 plus t. Okay. So I have drawn the generalized diagram of t minus tau diagram when t between 0 to 2. When t between 0 to 2. This is the case. Now what is your integration limit? We will complete this problem, please. See that. X of tau. Next, t between 2 to 3. Okay. So in this case, your signal sketch should become like this. This is 3. So 2 t minus. Okay. Next, t between 3 to 5. T 3 and 5. What about the signal sketch? 0, 1, 2. This is x of tau. This is x of tau. Three, 4, and so just assumption. Okay. This point 3, 4. This may be 3, maybe 4. So 3 to 5. So somewhere around like this. Okay, this is h of t minus tau. So this point is t. This point is t. This point is t minus t. Now overlapping portion is this much one. Overlapping portion is this much. Okay. So can you tell me the integration limit only? Then we will wind up the today's session. So already we analyzed step by step. Now only this figure is required for your exam in your answer script. So we concluded y of t equal to 0 for t greater than 5. Y of t equal to 0 for t less than 0. In between value, we are getting different kind of overlap. In between value, we are getting different kind of overlap. What is the integration limit for first case? See the figure and tell me the answer. Very simple. What is
0
the
to t.
integration? 0 to t. What is the integration limit for this case when 2 to 3? Starting
0
point
to
is
2.
0 to 2. 0 to 2. Last one.
T minus
Starting
3
point
to
minus 3. So t minus 3 to ending point 2. Okay. Then x of tau, h of t minus tau. In both cases, it is 1, 1 only. So you can solve it directly. 1 into d tau, 1 into d tau, 1 into d tau. Okay. So finally, you have to summarize your result. Finally, you have to summarize your result. What are the values you got it? Y of t. After integrating and substitute your limit 0 for t less than 0. 0 for t greater than or equal to 5. Greater than, that is correct actually. In between t between 1 to 2. Solve it 2 between 2 to 3. 5 minus t between 3 to less than 5. Okay. So please check this answer after solving this integration and substitution of your limits. Only the third problem is a bit difficult, but if you understand the concept, nothing is difficult for you. So like this, whatever may be the given problem, you have to analyze the problem first. From where to where the overlapping is available. How to solve this y of t, whether single step solving is possible or different kind of overlapping is required. So everything you have to analyze. Then solve the problem. In least case, below average student, some other problem also available in unit 2, that is step response. Okay, and properties of convolutions. Those topics you can refer. Thank you very much, and please go through this lecture once again and try to attend the convolution problem in the semester examinations. So next class we'll discuss discrete time convolution with the same pattern. I'll take 3 examples. I'll explain to you how to solve the convolution in graphical method for discrete time signals. Okay, and then we will solve some problem as per the student request, like Fourier transform some problem, and some student asked from unit 1 also. Please send me the problems. What problems exactly you want to solve, or which concept exactly you want to repeat. So I hope you understand. At least now you feel better about how to solve this convolution problem. Thank you. Any doubt, please stay back and other students can leave from the meeting.